Hi, my name is Aftab. I graduated from the University of Washington last year, and this is a project that I worked on pretty close to my graduation that I'd like to share with you. Um, During my time at UW, I developed a base in data science and machine learning. My thesis was in the area of predictive analytics in healthcare, so a lot of my understanding of machine learning models came from talking to different physicians, doctors, and getting to know what exactly the medical industry needs right now, what the challenges that we're trying to solve, and then coming back and talking to my advisor and professors and seeing how we can go about solving these challenges using machine learning. Um, I'm also hugely passionate about tennis. It's what motivates me the most. There's so much going on in tennis right now. We're in a golden age. Anyone who is in tennis knows that it's such an exciting time right now. On one hand, you have the veterans of the game like the Federers or Nadals who just refuse to give up and who just continue to keep winning slams one after another, even when you write them off. And on the other, you have all these new crop of young gen, next gen players who are constantly trying to push out these older guys. But it just makes for a really exciting rivalry, and it's an interesting time that we are in right now. So. Anyways, coming back to the topic, so I knew that it was only a matter of time before I used my base in machine learning to actually do something in tennis. Maybe when I started out, I was thinking maybe I can try and predict the outcome of a match using data science or something of that sort. But fast forward a few months, and I actually was able to create a framework that can predict. They can firstly aggregate and accumulate all of this tennis data from different sources on the web, and build machine learning models on top of it, and create a 3D visualization framework that can communicate these findings that the software tells us. And I published a video of some of these findings on YouTube, and it got some pretty interesting response, and got a lot of likes and comments and suggestions. But mainly my biggest plus coming out of this was I was able to get in touch with Holger. Holger.Jurna, he is a tennis coach from Germany. He got in touch with me through the video, and he said, "Hey, I saw this video. It looks interesting, and would you like to work together?" And from then on, we've been working together, and which is great because Holger, being a tennis coach himself, comes with a bunch of his own ideas, and it's interesting to see what is important from a coach's point of view. And he's also very technically sound. And I go about looking at the data side of things and seeing what we can actually do using the data that we have. So, how about we hear from Holger first, and then we can go into the details of her project.
Hi, my name is Holger. I'm a tennis coach from Germany, and I would like to introduce our project to you. Let me tell you what happened so far. Though I don't have a technical background, I strongly believe in technology and that it can help people and society in all areas. With regard to tennis, I believe that technology can provide players with objective data, thus helping them to understand the tennis game and why they win or lose their matches. In my search for technology experts to uncover the secrets of tennis, I found a video by Aftab on YouTube a couple months ago in which he presented his approach of data analysis and artificial intelligence, exemplified by a match of tennis professionals. We met online and since then have been discussing how to approach the subject of tennis analysis. Our current status is that the topic has to be addressed by two sides. First, data analysis. Second, video analysis. Data analysis is the first step and results in providing key performance indicators of top tennis players. This can be done by big data analysis. To improve the individual player, the second step is needed. By video analysis of a match, certain patterns of points won and points lost can be revealed. But video analysis is still a manual process and requires a lot of time and effort. Matches need to be watched, and each point needs to be categorized by a tennis expert. In this video, I'm going to briefly explain how tagging a tennis match works. So, first, I watch the point played in the match, and after the point ends, here the ball is out, I'm like selecting certain criteria like who served, who won the point, and what is the score, etc. Then I do this throughout the whole match, taking each single point, and the result is the match where I can use filters. So if I want to see all the points where this player served and the server won, I just select the filters and then I play all the points. So all the points then play in a row without pauses, and I can see for tennis coaches it's very important what happened when my player served, and did he win the points on his serve or did he lose the points on his serve. So this is a feature for tagging tennis matches. The challenge from a developer's point of view is to automatize the video analysis process by computer vision, object tracking, and machine learning. This would allow any tennis player at low cost to watch points of his or her match sorted by relevant parameters to understand the factors for winning or losing, and thus to practice systematically and efficiently.
So, as Holger mentioned, that was a video analysis part of it, but there's also a data analysis component. Actually, going back to video analysis, it's actually a really important and useful step when we talk to different coaches. They would like to see a points of a particular type in an aggregated manner because it's easier to find a pattern for a coach. But so that's the video analysis aspect. But coming to the data analysis, so when I started thinking that I want to build a predictive model, obviously the first thing I thought was I need data. But where do I look for data? I researched a lot on the internet and looked at multiple websites, but mainly the quality of data I saw was something like this, a very primitive, not very high quality data, just about match scores and who won the point, who lost the point, and just things like how many winners did he hit, how many returns did he miss, and things like that. But while this is a good, okay first step, it's not really helpful because, I mean, when someone loses a match, you don't want to be telling him that's because you won less points or the opponent won more points because that's kind of obvious. So I kept searching a bit more, and finally I stumbled across this talk by Jeff Sackman. So this is a talk at MIT Sloan, which is the sports analytics conference that happens every year, where people can come and talk about analytics in their sport. And so funny enough, most of Jeff's talk was actually about how about the sad state of tennis data right now and how there's very little data, public data available out there. So he actually most of his talk he went on to introduce something called a match charting project, which is a crowdsourced idea or where you can chart projects. And his idea was he released an Excel sheet template of a match. So if you look at this file here, the yellow column, you find a string of numbers, characters. So 5B, 7C, 2B, this means that it means something. So if you look here, it means that 4 means it's a wide serve, 5 is a body serve, F is a forehand, B is a backhand, and at is an unforced error, and things like that. So he has released this template out to people, and anyone who is interested can volunteer to watch a tennis match point by point and put this string of characters into the Excel sheet. So 6B, 4B17 probably means that it was a wide serve to the backhand of the player and he hit return down the middle, and the opponent went on to miss it or something like that. Um, and people actually do this for the entire tennis match. Why not? I mean, I thought I was a crazy tennis fan, but turns out there's crazier people than me. And initially, what you think is that this is not going to scale, it's too much effort. But strangely enough, it actually scales. If you look at Jeff's GitHub, and he has a GitHub where people can just clone it and chart a new tennis match and send across a pull request. So there's about 3,350 matches, which is fantastic because that's a lot of data. And considering that each match, say, about has 200 points, that is more than enough data to build a model with. Um, I took this data, wrote a few pre-processing scripts, and there were already some in the original repo as well, and came up with a more refined looking data set, which like this. So this is a data set of men's matches, and it talks about the shot direction. How many shots were cross court, how many were down the middle, how many were inside out, how many were inside in. As you can see, this is definitely more refined data than just saying who won the match or who lost the match or how many winners did he hit. And this is a serve direction that tells did he hit down the middle, down the tee, down the on the deuce side, on the ad side, and so this is a return depth that says how far from the baseline or how far from the net was the return the opponent hit. Was it very deep? Was it deep? Was it shallow? Was it returnable? And was it an error and things like that? And all of this, as you can see, is the high quality data. So I went about building some machine learning models with it. So this one, as you can see, is a model that looks at a match outcome 0-1, and depending on parameters like aces, doubles, faults, winners, unforced errors, serve speed, and return depth and rally length and things like that, it comes up with the most important factors affecting the match outcome. So if you can see, it says that unforced errors have the highest impact on affecting the outcome of a match. It has a 42% impact on the match outcome. The first serve, as in how many times you make the first serve, has a 16% effect. So this itself is interesting because down here you have the winners, which means that how many outright points did you play that the opponent could not get to the ball. But what it says is that what's more important is how many mistakes you make. So you don't want to make a lot of mistakes. And so I started looking a bit more into the data and found that this makes sense because in matches that you won, and I'm looking at matches for Roger Federer, who is my favorite tennis player, and in the matches that he won, the unforced errors is only 30, but in the matches that he lost, this is a way higher number. But if you look at the winners, it's pretty much the same in the matches that he won and he lost, which is probably why the decision tree understands that the unforced errors had the highest impact on the match outcome. And I mentioned, I showed a screenshot about rally length being at a disposal. So I looked at different rally lengths and found that keeping the rally short, playing short points, has a higher percentage chance of success for Roger Federer as compared to some other players. So you might want to tell him that, hey, keep the rally short and go for shorter points as opposed to just staying in the rally and playing long points. And this is one where I compared the depth of the returns that are hit between the matches won and lost. And oddly, I found them to be pretty similar. I was expecting to see that the deeper you hit, you have a higher chance of winning because the opponent has lesser time to hit the ball. Um, but I found it pretty similar. In fact, in the matches that you lost, you have a higher percentage chance of hitting the ball deep, which is a bit odd. But maybe the rationale is that the higher you hit deep, you also have a higher chance of hitting the ball long, which ends up losing a point. So you want to be somewhere between the baseline and the middle of the and the service line. So this was some of my machine learning attempts. But in order to communicate your machine learning models, you want to have something more than an Excel sheet to communicate your findings. So I went about trying to create a 3D visualization of a tennis court. I obviously started very small using some sketch diagrams like this. And then I started with a static image and moving an XY coordinate of a ball across the court. And this itself, I was like really happy because I hadn't done a lot of work with UI before. And I was trying to zoom into the ball, but as you can see, the clarity is lost. So I pretty early understood that you need something like a 3D visualization, like a 3.js model using JavaScript. So this is a model where I have a plane and I just move a ball in a 3D. But as you can see, there's a height component. This is something called a spline graph, where it's basically a quadratic Bezier graph, and I get the different points in the curve, and I draw a line between close points. And since the lines are drawn at very close intervals, you don't see a lag or anything. It feels pretty smooth. But actually, these are a bunch of lines across close points. And then I put it on a tennis court, and then I tried to get the curve for the ball. And then I replaced the black background with a texture. So I got an image of a grass, and I tried to replicate it. So there's actually a box inside of a box. The outer box is like a blue color sky, and the inner box is a green grass. And and then I replaced it with a ball trajectory of the spline that I earlier showed. And then I found something called a gas trail, which is it basically leaves a trail of the motion of the ball, and I put it into the code. And then I got like a court texture, played around with court texture. So if it's a French Open, you might want a clay court finish, or if it's an Australian Open, you might want like a hard court finish to it. And this is with the gas trail as well. Or if it's Wimbledon, you want like a grass finish to it, depending on where the players played. And finally, I came up with a UI like this, where you have the court, the grass, you have a little bit of physics with the net moving, as you can see. And you can upload an Excel, a JSON file of the match details. You can select which players' details you would like to see. Um, so in this case, I'm going to choose one of the players, um, Murat Safin. I'm going to choose, I want to say I want to visualize all his first serves and tell me where it went. And I can position my serves to which part of the court it went, and I can click on visualize, and it'll show me all the serves that went to the due side wide serves. So, and tells you the average height, average speed, and this all comes from the real data that we have. And these are the different positions on the court. So you have the serves going to the middle, the serves going to the ad wide, and things like that. And it can also show you a summary of all the serves. Probably get there in a minute. So this gives me a Hawkeye view of all the serves throughout the match. So as you can see, there's about 21% on the wide, and 21% down the middle, and split across the rest of the court. And if you want to know how far it was from the middle, I also have a court marker system where it tells you that it was 10 feet from the baseline or 7.8 feet from the baseline, and things like that. So it basically gives you a Hawkeye view of where your serves went, and so on. Um, So again, this is not, and we can do a code walkthrough. So basically, you position your camera. There's a bunch of things that goes with. So basically, you position your camera, and you set a renderer for the screen, and then you set the lights. Where do you want your lights to come from? And this affects how much lighting that I mean, do you want it to be a jet green chord, or do you want it to be a slightly olive green chord, things like that. And then you want to draw the floor and the sky, and then you want to view all of these together in one container. And once that is done, so this is the curve that I talked about, the ball trajectory. It's basically a quadratic Bezier curve, and then you get all of the points that are associated with that curve, and then you go about putting them in a queue or something, and then you go about drawing a line between very adjacent points, that is here. So it's an incremental tube and sphere, and so that's that. And um, um, and then you go about putting a color for the just the range that you can see. So I my range keeps changing, and I change the color for each of those ranges. And um, and I have some text action going on there. I can specify what text I want to see on the code, and do I want it to blink and things like that. I just play with the animation, delay, sleep kind of thing, and I animate accordingly. And yeah, and this is how I get my 3JS tennis court to show the ball action. So it's not the greatest UI or anything, but comparing with what I started with and what we are, it's a little bit of a I mean, it's something that it is positive. So, but we didn't stop there. We went ahead with the 3D modeling of tennis court, and 3D Max has an option of creating a model, a 3D model. So let me show you how to create a table. So here I create a table, a simple one. I make the four legs of the table. I create some more horizontal spokes. I am measuring the making sure that all of them are aligned and they are pretty straight. And so you can go to textures.com, and it lets you download textures. So here I downloaded a wooden texture for the table, and copied it, and added that as a texture. So I have a table, and I can save this as a JavaScript file. So I went on to create, not me, actually a friend of mine who was working with me went on to create some more similar 3D models. So that was a chair that you saw. This is a ball boy that you can put on the tennis court, and this is a speedometer. So if you want to measure the speed of the ball, this is a speedometer. And this is obviously the tennis court. It's again a 3D visualization of a tennis court. And you can export all of these as JavaScript files. So eventually, you will end up with putting all of these together. You would have a kind of get to the UI. Um, so putting all of these JavaScript together, you have a pretty smooth looking UI. So this was the chair that I showed you. This is the ball boy. This is the speedometer, and this is a ball that's moving back and forth. It's something that you can definitely work on, but I think you get the idea that 3D Max adds a whole new dimension when it comes to 3D visualization. So that's pretty much what I had, and as part of our current and future scope, we are taking baby steps. We're working with some tennis coaches or professional tennis players who would like to see something done on an need basis. Like, tell me in this point, in this match, what happened to all of the big serve points? Did I break down, or did I not concentrate on one aspect? Did I go for broke on some shots? Or maybe this might even be looking at the video analysis tool that Holger showed us, looking at Dartfish and finding where did I lose most of my points and things like that. But we also trying to work with some tennis academies, and Holger has a tennis academy himself, and working with kids and trying to better their game on a grassroots level. And I think this has a huge scope in the years to come, because on-court coaching is being debated, and it means that during the changeover between the first set and the second set, a coach can actually go to a player and say that, hey, this is what you did in the first set, this is what the opponent is doing, maybe you should change a few things, which means that the analytics could be happening during the time when the players are playing, and during a break, the coach could go and tell the player that, hey, this is what's happening. Right now, we don't have on-court coaching in tennis, but it is something that's being debated, and a lot of players and coaches are pushing for on-court coaching to be a part of the um, um, to be part to be allowed. And we need help. We need right. So I was just going back to um, right. So we would like to work with you together. If you're interested, please shoot us an email, and we would be glad and more than happy to bounce ideas off of each other and make a dent in this field. Thank you all for listening. It's been wonderful getting a chance to talk here. And both Holger and I have learned a lot in this process, and I think there's so much that we can do in this space. Thank you.